Hello, everybody. My name is Oz, and I'll be talking to you today about albedo and a little bit about myself. I am the PI of the Environmental Sensing Laboratory at the Civil and Environmental Engineering Department, Ben Gurion University of the Negev in Israel. My laboratory deals with many aspects of environmental sensing, atmospheric sensing, precision agriculture, greenhouse gas balance, soil science, and also satellite remote sensing for urban and agricultural purposes. So, why are we here? We are here because you enrolled to the Climate Med School and you chose the Albedo and Land Use subject. One of the main issues when dealing with climate change is understanding the global radiative budget. There are different things that influence the global radiative budget, like greenhouse gases that we know about CO2, N2O, and methane. Clouds in general impact global radiative budget, and also air pollutants. Some of them are greenhouse gases, and the other have a cooling effect, which is an entirely different subject. And here, in this research that we are going to do together, we will talk about two main things: albedo, which is the amount of radiation returned from the surface of the Earth to the atmosphere as carbon sequestration by vegetation, which is also called net primary productivity, net primary production, in short, NPP. So, albedo, as I said, is a measure of the return radiation from Earth's surfaces of the incoming solar radiation. There are different surfaces on the Earth. Some of them have higher albedo, meaning they reflect more light, like snow and bright soil. Others have lower albedo, meaning they reflect less light, like roads and dark soil. And this depends on the radiative budget of Earth. Unlike other surfaces, vegetation has a unique difference, but vegetation has a relatively low albedo. It reflects less light, but it has another great impact on the radiative transfer budget. Vegetation sequesters CO2, what is called the net primary production. By sequestering CO2, it removes it from the air, from the atmosphere. And we all know that CO2 is a significant greenhouse gas. So although it has low albedo, it absorbs more light, by the way, for photosynthesis mainly. It also reduces the global warming by removing CO2 from the atmosphere. So it has two functions. One is warming because it absorbs the radiation, it absorbs the energy and leaves it on Earth. And the other is cooling, removing the CO2, removing the greenhouse gas from the atmosphere. So both albedo and NPP have a significant role in the radiative budget. And it is very interesting because in some cases, like in desertification, we have them competing each other. On one side, we have vegetation, and on the other side, we have bright, bare soil. So, what is better? Which has a higher cooling effect? What do you think? Considering the increase in global population and the upcoming climate event, we know that in many areas, the land use is going to change. Some examples are agricultural land abandonment that due to climate change and desertification, their yield will be reduced. Natural vegetation removed due to urban development. We need more space to live in because our population is growing. Other places are going through reforestation or deforestation, depending on the growth. So in this research, we want to investigate how the albedo and NPP changed in the past 20 years. And we want to try and connect these changes with climate change and also with socioeconomic changes as well. Furthermore, after dealing with the general albedo and NPP, we want to focus on agricultural land creation and development. We want to investigate what is the role of climate change in agricultural land use change. We know that climate change can cause a reduction in yield due to low precipitation and high temperatures. We also know that climate change can also improve yield a little bit because increased CO2 concentration. We want to locate the areas that were changed due to climate change and see how the agricultural land use change impact the socio-economical changes in the area of interest. To do all the things that I mentioned, we're going to use several data sets. The first one is our data sets that are based on modest observations. Modest observations are here from around the year 2000, and they measure daily in spatial resolution of 250, 500, and 1,000 meters. They measure in 36 bands, and you can get different information from NASA. Specifically here, we are going to concentrate on NPP that was generated using MODIS, and also land use data that was generated using MODIS reflectance observation. In addition to MODIS, we are going to use MERA2. MERA2 is a data set that exists from 1980. It has a spatial resolution of around half a degree, and it includes different climatic parameters from albedo that we will use through precipitation and temperature that we are also going to use, fluxes of gases, aerosols, concentration of different gases like ozone, and we will of course use them together with the information promoted to investigate what is the connection between albedo and NPP, and also what is the connection of agricultural land change to climate change. So I hope you're going to enjoy this. Good luck.